So first we must calculate your project's embodied carbon emissions, and we can start that on the home screen. If we scroll down here, we have two widgets. One that tells us our project's embodied carbon emissions based on the materials and equipment. So this project is 25.5 kilotons. And a second that looks at how a week of delay affects different WBS components. By clicking on this arrow here, or by going into CO2 management and overview, we are able to dive down, and we'll do that now. So here we've got our project's carbon S-curve. We've got our total carbon footprint here, and an interactive S-curve that tells us at any point in time what the baseline carbon and what the selected schedule's carbon is. And of course, you can change the baseline just how we've done previously. The graph is interactive, so we can turn these graphs on and off. What we can also see is how it compares against the baseline directly in words. And this is an output of the natural language processing module. So the selected schedule produces 25.5, which is a 1.3% decrease compared to the baseline. We can see how that 25.5 is broken down between materials and equipment. So we can see that materials, and if we hover over, structural concrete, piling concrete, and steelwork make up 80% of all of the embodied carbon emissions of this program. And of the small amount that is equipment, we have bulldozers, cranes, excavators, and excavators for both earthworks. Now, a point of note, how equipment is calculated, we take the equipment, we understand the idle to active times, we understand the emission profiles from the running of that equipment, i.e., for example, the diesel emissions, we take duration of activities, and then we calculate the use of the equipment, hence this. What we generally find is that concrete and steel make up about 90 to 95% of all large construction works. What you also have is you have a number of insights here from which you can dive down and start to ask more details.